Hello, and welcome to my Pre-Algebra review series. This video covers Chapter 8, Section 1, titled Volumes of Cylinders. By the end of this video, you will have reviewed recent lessons regarding finding the volume of a cylinder and finding the height of a cylinder. You will also have a chance to look at a couple real-life problems that will help you to round out your concept of space usage within a cylinder. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and it certainly will help this channel to be seen by more students. If you'd like me to cover any of these topics in greater detail, please leave a comment in the comment section below. I read them, and I do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thanks, let's get on to it. Okay, a key idea, volume of a cylinder. The volume of a cylinder is the product of the area of the base and the height of the cylinder. The formula for the volume of a cylinder is as follows. V equals B, and it's always like capital B, as we use it here. Capital B times H, the height, where B is the base, and it is equal to pi r squared. If you remember, the area of a circle is pi r squared. That's the radius squared. The height of the cylinder is shown over here on the side. Over here, the height is from here to here. That's the height we're measuring. That distance from there to there, the height. You multiply the base, the area of the base, times the height, and you'll end up with the volume of the cylinder. Okay, example 1. Find the volume of a cylinder. So there's shown in the picture a cylinder on the right-hand side, and it's showing us that the radius right here, from here to here, is 3 meters, and that the height from right here to down here is 6 meters. So let's take a look and see what it comes up to. Find the volume of the cylinder, round your answer to the nearest tenth. Okay, so we start off with the formula. V, volume, is equal to B, the base, times the height. And carrying this to the next step, then V is equal to pi, right here, pi r squared. We know that pi r squared is the area of a circle. And then we're going to multiply by the height, again the height. So what is that? Taking it, let's put the numbers in. V is equal to pi, 3.14, okay, times 3 squared times 6. What's 3 squared? We all know that it's 9, right? So the volume is equal to pi times 9, the volume of the circle, or the area of the circle, excuse me, times the height, 6. Okay, so now when we multiply this out, V, the volume, is going to be equal to 54 pi. And you notice here, up until this point, we've been saying that everything is equal. It says equal, equal. The volume is equal to, and we're using the term right here, pi. And the moment, and right here it still says the volume equals 54 times pi. And that is absolutely true, and that is the exact absolute volume of this cylinder. Then all of a sudden, then you see here that we have this symbol for is similar to or approximates or whatever that symbol truly means. It means is approximately 169.6 meters cubed. But why did it go to approximate? It's because we've multiplied by the approximate value for pi. Pi is equal to our approximate value, 3.14. Okay, it goes on, 14159, it goes on. But the point is, once we convert to the decimal version, we can no longer say pi is equal to this. We have to say pi is approximately equal to 3.14. So the volume is approximately 169.6 meters cubed. So therefore, the volume is about 169.6 meters cubed. Okay, example 2. So now let's find the height of a cylinder. Find the height of a cylinder, round your answer to the nearest tenth. Again, what is the volume of the cylinder? We know the formula. V is equal to the base, right here, the base times the height. And this formula is now pi times r squared, the radius squared, times the height. Volume is pi r squared h. So here now we have 314. They're telling us, look over here, the volume, they're giving us the volume. We can't find the height without two pieces of information. It's a three-piece puzzle. We have the area of a base, we have the height of the cylinder, and we have the volume of the cylinder. You can't find one without two of the others. So in our case, we know 314 inches cubed, it tells us right over here, is the volume. And we know that pi r squared is the area of the circle. And we know that as we see here, the diameter, they're showing us the diameter of this cylinder is 10 inches. So that means what? That means that the radius is half of that. So going back to the equation now, we have 314 inches cubed is equal to pi times 5 squared. The radius is 5. So the diameter is 10, the radius is 5. 5 squared times h. H is still a variable. We can't solve it, not quite yet. So now we have 314 inches cubed divided by, so we took this, if you multiply pi times 5 squared, you get 25 pi. So here it is. And this is pi, or 25 pi times h. We're now going to divide both sides. Both sides are going to be divided by this number here. Well, that number there is right here, except we've multiplied out the 5 squared. So it's 25 pi. And it's inches squared now. Keep that in mind. This is inches. Over here is 10 is inches. The radius is inches, but we're squaring it. Right there. So now that we've got inches squared, we have the inches squared here on the bottom. That's where the squared comes from. So now 314 inches cubed, because that's the volume, divided by 25 pi inches squared is equal to the height. Well, when we divide this out, we're now going to get that the height is approximately 4 inches. And here we go again. Why does it say approximately? It's because we've converted pi to its decimal equivalent of 3.14. And the inches cubed divided by inches squared ends up being just plain inches. I'll write inches here, inches. The cubed divided by the squared leaves you with just 1 inches left, 1 unit of inches. So it says the height is about 4 inches. That's the answer here. Okay, exercise 1 on your own. So you know what that means. Find the volume V or the height H of the cylinder. So there's 2 different problems here. Round your answers to the nearest tenth. Okay, so go ahead and give it a shot. When you come on back, we'll do them together. Okay? Okay, so now that you're back, okay, the directions. Find the volume or the height of the cylinders. Round to your nearest tenth. So for problem 1, we know the standard formula. V, the volume, is equal to the base times the height. And we extend that formula to include the true area of a circle. And now we have volume is equal to pi r squared h. So this problem here is looking for V. As we see down here, it's looking for V. And I'm going to switch this to a different color. We see that this is looking right here for the volume. So I'll go back now to orange. Okay, so, oops. Gotta get rid of that. Oh, nope, it doesn't like me to do that. Okay, so now that we have this, let's extend it. So we want the volume. So the volume here is equal to what? The volume is equal to pi times what number? Well, times the radius. And what's the radius? Right here, 4 feet. They're showing us it's 4 feet from here to here. So 4 squared times h. And what's the h? It's 15 feet. So we're going to put in 15. And we're going to multiply this. So now what is it? The volume is equal to pi. 4 squared is how much? 16 times 15. Okay, so the answer here is with pi left in place. It'll be the exact answer of the volume of this cylinder. The volume is equal to, and I'm going to show the numbers first. This is 240. 16 times 15 is 240. So it's 240 pi. So that's 240 times pi. If you extend it out completely, you're going to use the decimal equivalent of pi, we're going to get an answer rounded to the, and they're assuming you will, because they're up here, they're saying round your answers to the nearest tenth, so we're going to divide or multiply or whatever it requires. If we multiply 240 times 3.14, we're going to get a volume equal to 754, okay, feet, what? Cubed, squared, what? Cubed. Why is it cubed? Because this is volume. Okay, so there's our answer. So there's our answer. And rounded, we don't have to round. It's 0.0. I guess we can do that, but we're going to do 754 feet cubed. Okay, there's the answers on that one. Let's go to our next one. Again, volume is equal to the base times the height. We'll extend the formula to show the nature of the base, the area of a base, which is the volume is equal to pi times r squared, and then the volume is times h. And this time they want us to find h. Over here we see that, I'll change this out to identify it. You see right over here, it's very light. I'm sorry about that. But it's h equals something. They want height. So we're going to solve this equation for height. Going back to my golden colors here. So the volume is what? As I look at it, it's 176 cm. Oops, darn it. Darn. Where's my pencil go? Sorry. cm cubed. That's the volume, and it's equal to pi times r squared, and r is, it shows us here that the diameter from here to here is 8 centimeters. We want 4 centimeters squared times h, and we're going to be finding h. That's what they want us to find. So now if we multiply and divide, we're going to come up with 176 centimeters cubed equals 16 pi is equal to 16 pi times h. 4 squared is 16. So now when you multiply this out, we're going to get, or divide, actually we're just going to divide, we're going to end up getting 176 centimeters cubed divided by, because we're going to take this 16 pi and divide both sides by 16 pi. So we're going to divide this side by 16 pi. And then that's going to be equal to h. And so what is h equal to? H, if you divide 176, and I'm going to put centimeters squared, cm squared, because we're squaring it right here. Here's where we're squaring the centimeters right there to make centimeters squared. And went left with just centimeters, because the centimeters squared and the cube divide out and you end up with centimeters. And the answer ends up being 3.5 centimeters. Okay? And that is, another thing we got to look at here. It is not 3.5 centimeters. It's approximately 3.5 centimeters. Okay? Approximately 3.5 centimeters. Okay, example 3, a real-life application problem here. So it says, how much salsa is missing from the jar? So they're looking for the negative space, right? They don't want to know how much salsa is in jar. They want to know how much is missing from the jar, okay? What's missing from the jar? And they're telling you what is in the jar, and you're going to have to figure out what's missing from the jar, okay? So it makes it a little more complex. So using our standard formula, this is a cylinder. So the jar is a cylinder, so we have volume is equal to the base times the height, and you know, yes, the volume is equal to pi r squared times the height. And so the volume is what? What is the volume? Well, pi stays pi. What is the radius? It tells us right here, the radius from here to here is 5 centimeters. So it's going to be 5 squared times, why do I have 10 minus 4 here? Why is it 10 minus 4? They gave us the overall height is 10 centimeters. They told us how much is left, 4 centimeters. So what the missing piece, because they want to know what's missing from the jar, the missing piece is 10 minus the 4. So what's missing is 6, right here, 6 centimeters. So now we have the volume is equal to pi times 25, which is 5 squared, times 6. And that comes out to 150 pi. 25 times 6, 150 times pi. Here's our exact answer. See, V equals the exact answer of 150 pi, or the approximate answer of 471 centimeters cubed. Okay, and where do we get the cube now? Well, we know that there's squared centimeters right here. Right here, this is centimeters because it's 5 centimeters, and you're squaring it. So there's 2 of them. And then when you multiply by the third of them, which is right here, is the 6 centimeters. Excuse me, you get squared times another one, which makes 3. So it ends up being cubed. And that's where the cube comes from. So there is about, again, the word about, there's about 471 centimeters cubed, or cubic centimeters, of salsa that are missing from the jar. Okay, example 4, another real-life application. How many gallons of water does a water cooler bottle contain? And they're giving us a little note here that 1 cubic foot of water is equivalent, approximately equivalent, to 7.5 gallons of water. We're going to use that to do a conversion here when we're down. Okay, going back to the beginning, volume of a cylinder is the volume is the base times the height. And we know that the base is pi r squared. We need the radius, and it kind of takes care of itself. We know what the height is. They're going to tell us. So in our equation, we're going to do some substitution. The volume is equal to pi times 1/2 for 0.5 feet squared. So if I look down here at the bottom of this water cooler, the diameter is 1 foot. So that means that the radius is 1/2 a foot, 0.5. And I have the feet in here because we're going to square it. So you see the feet squared. The units get squared. So when we do that, we're going to get pi times 0.25 feet squared. And 0.5 times 0.5 is 0.25. And then we're multiplying by 1.7, the height of the water in the water cooler. So now when we multiply this out, we're going to get the volume is equal to 0.25 times 1.7. It's going to end up being 0.425 pi. Pi is still intact. We're still using the equal sign. Or about, here's the about word, 1.3352 cubic feet. And why is it about? Because it's pi, oh, here it is right here. Pi has been converted to probably 3.14. Okay, so there's our answer. It's either 0.425 pi cubic feet or 1.3352 cubic feet approximately. So now that we know that the bottle contains 1.3352 cubic feet of water, it's right here. We know that. Came from our solution right here. And we know that it's approximately up here at the top. I'll change a little color here. We know that right here, 7.5 gallons is approximately equal to 1 cubic foot. So for every cubic foot of water, we can multiply it by 7.5 gallons. Okay, 7.5. This formula is written down here. So the gallons, the total gallons, is equal to how many gallons do you have? How many cubic feet do you have? Because we're going to convert these cubic feet to gallons. 1.3352 cubic feet. And that's times the conversion factor. And they gave us the conversion factor. And that is 7.5 gallons per 1 cubic foot. And when you do that, the cubic feet cancel, and what you're left with is gallons. And 1.3352 times 7.5 is 10 gallons of water. And it is approximately 10 gallons of water because we've multiplied out, and you know we multiplied out the pi. As a matter of fact, even this is an approximate down here, but we could have wrote approximate right here too. We didn't do that. It's all approximate. Once we got rid of pi in our answer and started rounding, got rid of pi and started rounding. Right here, there was a rounding job because of that. That's what happened. Okay? There's our solution. Okay, exercise 2 on your own. I'll read them to you. What if, in example 3 above, that's the previous salsa problem, the height of the salsa in the jar was 5 centimeters. How much salsa is missing? Same problem with just a different value, 5 instead of 4. And the other problem is the cylindrical water tower has a diameter of 15 meters and a height of 5 meters. About how many gallons of water can the tower contain? So that's going to be a conversion problem. We did that earlier with the feet, the cubic feet. So let's go ahead and start off. I'll let you go off on your own. When you come back, we'll go over these together. Okay, now that you're back, let's give it a try. So we know the volume, the formula for the volume of a cylinder is volume is equal to base times the height. And now I'm going to rewrite this to expand on B. So the volume is equal to pi r squared times height. And when I fill in the missing values, we're going to have the volume is equal to pi times, what is the radius? The radius is 5 centimeters right here on the top. We see it, 5. That nothing's changed there. 5 centimeters, so 5 cm, I'll even write that in there, squared, times 10 minus 5, because I said 5 were missing, or 5, what does it say? The height of the height of the salsa in the jar was 5 centimeters. So they want to know what's missing, so we got to have to subtract the 5 from the 10, and we get centimeters here. And when we write this out, volume is equal to 25 centimeters squared pi times 5 centimeters. Okay, cleaning that up, we have the volume is equal to 25 times 5 is 125 pi centimeters squared times centimeters cubed. Okay, that's the answer. Now, that's the exact answer because we've left pi in the problem. If we were to now get rid of the pi and expand this to include the approximate value for pi, which is 3.14, we'll find out that the volume is equal to, what is it? It's 392.7 cubic centimeters. So I can put that down here. 92.7 centimeters cubed. So that's what's left in here. Let's go to this tower. It's going to be a little tougher problem. These numbers might be a little bit bigger. I might have to even stop and get a calculator out. So it says a cylindrical water tower has a diameter of 15 meters and a height of 5 meters. How many gallons can the tower, how many gallons can the tower contain? Well, it's a 15 meter diameter, so that means that the radius is going to be 7.5. So I'll write out the equation. The volume is equal to pi r squared times height. And we know the volume then is going to be equal to pi times 7 0.5 squared times h. And I could have put in for h, I could have put in 5. I didn't. So we'll do it this time. So the volume is equal to pi times 7.5 squared ends up being, let's see, what is it? 56.23. That doesn't make sense. Okay. 56 times 56.23 meters squared times 5 meters. Okay, so now we multiply this a little bit further. We get 556.23 times 5 ends up with 281.25. Let me erase that. I got distracted a little bit. 81.25 pi, because there's pi is still in the equation. It's right here is the pi. It's still in the equation. Okay, and if we multiply that times pi to get the approximate value, we're going to find out that I'm just going to say, or approximately 281.25 times 3.14 is 883.57 times 57, and it's meters cubed. Okay, so now we know that the volume is 883 meters cubed, and a half meters cubed. And we know the conversion factor is, they told us up here, is 264 gallons per cubic meter. So now if we say the volume of the tower, I got a volume of the T here, is 281.25 times 264 gallons per meter cubed. And this is meters cubed over here, by the way, meters cubed. That's up here. So then we have an answer of the volume of the tower is equal to 281.25 times 264, and the meters cubed will disappear, and we'll end up with an answer of 233,263 gallons. So this tank will hold approximately, this is approximately now, approximately 233 263 gallons. Okay, I hope you got through that the same way I did. The important thing is the conversion factor and knowing how to set it up. And the key was that we're converting to gallons. So when you have a conversion factor like this, the units you're converting to is the units on top. So in our case, it was 264 gallons per meter cubed. If we were going from gallons to meters cubed, you would have said 1 meter cubed divided by 264 gallons, because you were at gallons, so then the gallons would have canceled out and you'd have been left with meters cubed. In our case, the meters cubed are canceled out and we're left with gallons. Okay, hopefully that makes sense.